All right, so let's take a look at some homework problems here. Question 17 reads, the price of a home in thousands of dollars is associated with the number of square feet in a home. Makes sense, right? The bigger the house, I would assume the more it costs. Home prices in Smallville can be modeled by an equation. Oh, okay, let me write this down. So the model for the equation is in Smallville is 150, and it says these were in thousands of dollars, right? So 150,000 plus, we're going to write down 0.041 A, where P is the price of the home in thousands of dollars, and A is the area of the house in square feet. All right, got it. Oh, and then there's another neighborhood here. We've got Fancyville. It says home prices in Fancyville can be modeled by price is $250,000 plus 0.198 A. All right. Knox saw a real estate advertisement for a 280,000 square foot home that was selling for $280,000. Okay. So we got the price is 280 in thousands of dollars, and the square footage was 280,000 square feet. No, 2,800 square feet. Which city would she predict the home is in? Okay. So my take on this is, which one of these models, so this is what I'm plugging in, which one of these has, I guess, the smaller residual, right? So apparently the actual price, and I'll write this down in thousands of dollars, is $280,000 for 2,800 square feet. Which one of these has the smaller residual, meaning that it's probably fitting in better with one town or the other? And our two towns are Smallville, Ohio, and Fancyville. That's an obnoxious name. Fancyville. All right, so let's go ahead and plug these numbers in. So I'll just grab a calculator real quickly here. And for the Smallville, I'm going to take on 150 plus, let's see, I've got 0.041 times 28,000. That gives me a predicted price of $264,800, right? So remember, this number is expressed in thousands, so I would move the decimal place 3 to the left. So that's what that one is. Okay, that's not bad, right? That's if I look at the difference between these two numbers, this could be, it could just be a lot lower priced home in this neighborhood. Let's see what Fancyville's looking like. So for Fancyville, I'm going to have 250,000 plus 0.0198 times 2,800. And that's going to, ooh, really? 305.44. Okay, so that's the predicted cost in Fancyville. So you can see what's interesting is, like, this house has a cost that's kind of above what would be predicted in Fancyville. I mean, above what would be predicted for Smallville, right? Smallville is predicting the price should be 264.8, and Fancyville is predicted it should be 305.44. So this house price is right in between the two. Let's take a look at the difference in those. So I'm just going to take 280, that's the actual, minus the predicted 264.8, and when I do that, I get a residual of positive 15.2. Oh, the residual is actual minus predicted. I did actual minus predicted. Okay, so for the other one, the actual was 280,000 minus the predicted of 305.44. So this is below it. So this one's residual is negative 25.44. So I would have to say, I mean, it's tough to know, because what do they always say? They always going to say, you want to buy the worst house in the best neighborhood, right? Because you could fix up the house, but it's the worst house in the best neighborhood. So I really don't know, but I would say, based on the fact that the residual is closer here, I would say that I would predict the house probably was from the town of Smallville. And I'm just saying that because the price that I'm getting, the predicted price is a lot closer. It's closer by about $10,000 than the predicted price from Fancyville. Let's move on to the next question. Calculator away. Come on up here. All right. A team of students is trying to answer the scientific notation problem. Okay. I see that. George think they should use a generic rectangle because there are two terms multiplied by two terms. Cadell thinks the answer is this, but she can't explain why. Lauren thinks they should multiply the like parts. So multiplying the 2 times 4 and the 10 times 10. Who is correct and explain? Okay. I'm going to play referee here. First of all, this whole thing about there's two terms, there's not two terms. Terms are those things that are separated by addition or subtraction, right? There's no terms. In fact, this whole thing is just one product, so there's just one term there. And if I was to rearrange the terms, I could rearrange it because multiplication is commutative. I could write it as 2 times 4 times 10 to the third times 10 to the 7th. And 2 times 4 is the number 8. And 10 to the third times 10 to the 7th, right? This is literally 3 factors of 10 times 1, 2, 3, 4, 5, 6, 7 more factors of 10. That's 10 factors of 10, right? So the answer is 8 times 10 to the 10th power. So who's right? Cadell. And he can't explain why. Maybe you can now, right? Maybe you can now. I'm sorry, George, there are no terms there. There's just the one thing. There's no plus or minuses. And this bit about, I mean, yeah, clearly the 2 times 4 is 8, but when you multiply 10 to the third times 10 to the 7th, you're just multiplying all the numbers. This is definitely not what you get. You would get 10s are being multiplied, and I have 10 of them. 3 plus 7 is 10. All right, let's move on to question 19. 19 says, calculate the following values if possible. Oh, okay. So this is telling me that the output of the function is the number 16 when the input is a. Okay. So basically that's saying the output of the function is 16 when the input is a. So basically right here, when the input is a, that function produces an output of 16. So I can just say, well, I don't know what a is, but I know if a goes in, 16 is what comes out. So that's 16 minus 2, which is 14. So 14 is the correct answer for A. B, I'm going to think about, because I don't know if this is square. I mean, basically, if it was linear, I would say doubling the input. Well, no, I would have to say if it went through the origin, if it was, what do we call those? Things that go through the origin and they have this consistent slope, we call those proportions. If it was a proportion, doubling A would produce a doubled output of 32, but I don't know that it's a proportion. I can't assume that. So I don't think I can answer B. But I can answer C because I know, and this is the one thing I know, is that when A goes in, 16 comes out of this function. So you can see right there it's saying, hey, A is going in. What comes out? 16. So this is going to become 3 times 16, and then I've got the plus 2, and I'm not ashamed. Well, I'm maybe a little ashamed, but I am doing 3 times 16 is 48. Okay, and 48 plus 2 is the number 50. So I'm pretty sure that A is 14 and C is 50, and I don't think I can answer B. I'm going to be honest, I did peek at the answer key, and I think I have a slightly different understanding of this function now, based on the answer that I saw they gave for part B. So I think what's happening is I think this is saying, maybe I was saying when A goes in, 16 comes out, but if that's a variable, I guess I could think of this as this function is whatever goes in. It doesn't matter what you put in, right? 16 comes out. So if I'm interpreting it that way, like A is not, like I was thinking like maybe A is the number 7, right? And every single time I saw A, like when 7 went in, 16 came out. But if I interpret A to be really a variable, then it's saying whatever goes in, 16 comes out. Well, if you double whatever, right, it doesn't matter what you're putting in. If you double it, because it doesn't matter what you're putting in 16 still comes out. If you interpret that problem that way, then when you put in twice A, right, you should still get out 16 exactly. So this is the answer the book has, and I think I understand why they're saying that now, because basically I'm in their perspective, I'm just assuming that A is any value. So if I was to think about what a function would look like regardless of what you put in, 16 always comes out. It could look like this, right? It could be f of x equals, you could say 2x divided by 2x plus what? Plus 15. You could do that. No, that wouldn't work. Well, it wouldn't work in the case that x was 0, but as long as x isn't 0, well, that would be a division by 0 problem too anyways. But as long as x is not 0, right, anything that goes into that function is going to produce an output of 16, because if I put in 10, it would become 20 over 20, which is equal to 1, and 1 plus 15 is 16. So this is an example of a function that would produce an answer of 16 all the time, except for one notable exception, when x is 0. Hey, let's move on to our next question. Okay, it says write an equation for the following situations. You do not need to solve it. Laura takes very good care of her vehicles. She owns a blue van and a red truck. Okay, 2 vehicles, a blue van and a red truck. Although she bought them both new, she has owned the truck for 17 years longer than she has owned the van. The sum of the ages of the vehicles is 41 years. So if I add their ages up, I get 41 years. It says, so I'm just writing an equation. I don't need to solve it. Write an equation. Okay. So let me do this. I'm going to say, although she bought them both new, she has owned the truck for 17 years longer than she has owned the van. So she's owned the truck longer. So based on that sentence, I'm going to make my variable be v, and I'm going to say let v be the number of years she owned the van. All right, and the reason why I picked that was because I noticed that it's giving me the age of the truck in terms of v. In fact, I could say if v is the number of years that she's owned the van, then the number of years she's owned the truck is v plus 17. You see what I did, right? She's owned the truck for 17 years longer than the van. So this is the truck, right? This is the truck because it's 17 years more than the van. So if I add the ages of her 2 vehicles up, I get 41 years. So V is the age of the van plus V plus 17 is the age of the truck, and together that's 41 years. We'll just leave that there. We're just going to leave that there. Let's see, 21. Not the last question. 21. Plot triangle ABC on graph paper with points blah 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 blah. Duh. Use this function to transform ABC, graph and connect the new points, then label this triangle. Describe how ABC has been transformed. What, if anything, about the original triangle has been preserved in this image? So when I graph these things, I got A was at 2, 2, B was at -2, -2, and C was way over at X is 8 and Y is -2. Is that correct? Yes. X is 8, Y is -2. And it says to transform it using this rule. And what the rule says is that any X, Y point is going to go to a new point where X is going to become the opposite of X was, and Y is going to become the opposite of Y. So if I was to move point A, A is at 2, 2, positive 2, positive 2, and it's going to go, A is going to go to, that's interesting, A is going to go to exactly where B is, right? So when I do this transformation, this point right here is going to be A prime, because A was at the point 2, 2, and now if I multiply each one of these by -1, A prime, the image of A, is going to go to -2, -2. And actually the same thing's going to happen to B, right? B is at -2, -2, and if I multiply both of those by -1, right, this is where B is going to go. So this is going to become B prime. C is going to become, oh, that's nice. So C is at X is 8. If I write this down, X is 8 and Y is -2. If I take the opposite of each of those, C is going to go to, X is going to be -8 and Y is going to be +2. So C is going to now live way over here at 8 plus 2. So this is my new C. This is the new C. So this is C prime. So this triangle, right? This triangle, oh, that's cool. That looks like a parallelogram, right? This triangle moved. And what's weird is this side that was A to B, looks a lot like the same original side, except through that transformation they switched places. I actually think that's the same as a rotation. I think it's a rotation of 180 degrees around the origin too. So I'm pretty sure that this rule that we're written here is the same as a 180 degree rotation, either clockwise, or as we learned earlier, or counterclockwise. It doesn't matter which way you go. If you go clockwise or clockwise 180, it lands in the same spot. Okay, so that's my answer for A. Let's see what they got in plan for B. Okay, B. Now use a different function. It's a lot like the old function, but it's different. To transform the original triangle to create a new one with double prime. So I'm going to be looking at the original one, and I'm going to move it using this new rule. So let's take a look at this new rule. Okay, so this new rule I'm going to write down here. I got it memorized. X comma Y is going to go to, I'm going to take the opposite of 2 times the X and the opposite of 2 times the Y. So let's think about where our original triangle went. So A was originally at 2, 2, but I'm going to double those and take the opposite. So that means that this new A is going to go way over to -4, -4. See what I'm talking about? That point right there, that is the A, and they said label this one double prime. So the new A got pushed out that way. The B was at -2, -2, and again this rule says multiply each of those coordinates by the number -2. So this is -2 times -2 is +4. Same thing with the y. So this new point B is getting pushed way over to 4, 4, right? X is 4, y is 4, and this is my new B double prime. And then it says do the same thing for C. Oh man, 16 is not going to fit on my graph paper. I'll have to approximate it. So if I double that and take the opposite, so positive 8 is going to go to, so this is the new, this is going to be C, it'll be the C double prime. It's going to go to negative 16 and positive 4. Again, all I did was I multiplied each of these points in the original C by the number negative 2 to get this. So, okay. I know definitely y is going to be at positive 4, so it's going to be on the same y value as this b double prime, right? So it's going to be up here, but then there's 12, and I got to go from there, 12, 13, 14, 15, 16. This is ridiculous. I should have had bigger graph paper. So this is going to be my c double prime. So what's happened to this triangle, right? It did flip just like when I went to the C prime. It did flip like it, but look at this. It got bigger. Like in fact, did it? Did all the dimensions grow by a factor of 2? Maybe. Because this the original one, this length right here was 1, 2, 3, 4, 5, 6, 7, 8, 9. That was 10 long, and the new one's 20. Maybe. Is it? That's 4 plus, that's 12, 13, 14, 15, 16, 17, 18. Yeah. So I think having this factor of 2 made this one grow. This is definitely not in a rigid transformation, right? This is one of those transformations, but it's a dilation. So I've made in this case, because the value is 2, right? It's made it larger. If the number was like a value like between negative 1, I mean between 0 and 1, somewhere in there, it would make it a smaller triangle. But this one definitely made the triangle larger. So it says, what if anything about the original triangle has been preserved? Well, I would say it's the same shape, right? It did have a reflection or maybe some rotation, right? But it has definitely undergone a size increase. It says, has this triangle undergone a rigid transformation? No. If you're asking me if it's a rigid transformation, no, because it got larger, right? A rigid transformation would preserve the shape and size. This one got larger, so it's definitely not rigid. But it does look like it's the same shape. It's just a bigger version of it. All right, last question, 22 on the homework. It says rewrite each of the following using the distributive property. So they're products, and I'm going to make them into sums. This first one is just a monomial times a binomial. For convenience, I could make an area model, right? So on the area model, I could have a 5x, and then this is an x, and this is a negative 6. The value that goes in that first box would be 5x squared, and the value for the next box is negative 30x, right? So I just write 5x squared minus 30. On the next one, I'm multiplying negative y times both of these terms. So again, I'll use an area model. Don't typically do this for monomials and binomials. So I've got negative 9y. This is 6, and this is negative 3y. 9 times 6 is 54, so this is negative 54y. And negative 9 times negative 3 is positive 27, and this would be y to the second power. So if I was going to write that in standard form, I would write the 27y squared first, and then minus 54y. All right, I think that's it. I think we just went through question 22 today. So that's it. Mr. Roberts is out of here.